So let us start our today's session or our today's workshop. That is workshop 2. It's titled as Terminologies of Practical Electronics Engineering. I think that I've introduced myself in previous workshop. So let us focus, and we have the homework here, which we left for students to try. The first question, students, I have some local students here. So read the first question.
What is applied mathematics?
The word applied mathematics. That's the first terminology, right? And then the fifth terminology is electronics engineering. The homework was, what is electronics engineering? Then the sixth terminology is what? Theory. Then the question is, what is what? Theory. What is theory? Okay, then the seventh terminology is practical. Then you have the questions of what is practical. So I know you have found different definition, but our intentions is not only to know the definition of these technologies. Our intentions is to see electronics and actually to build in our mindset the transition from the theoretical engineering concepts or from the science to the practical engineering. So for example, if you know what the meaning of theory, then you have to think, because the branch of engineering that you are learning in this module or in this course is electronics. So you have to think, what is electronic theory? Is there any difference between electronic theory and electrical theory? Those are the questions that you have to ask yourself, right? And then practicals, what are the electronics practicals? How can you do those electronics practicals? You should have the A, B, C, D about them. But before I teach you about some important or some relevant definitions of these technologies, I still have something to talk in engineering, because this is the cornerstone, this is the fundamental of the module or course that we are learning, right? Yesterday I gave you how many definitions? One or two? One. Two, right? So engineering is the purposive use of what? Or science. Refer MIT, it's course MIT 6602. And then the second definition is engineering is applications of science and mathematics to solve problems. While scientists and the inventors come up with innovation, it is engineers, so I think that here I forgot an N, it is engineers who apply the innovations or discoveries to solve real-world problems, right? So I still have some few definitions that I want to share with you that can strengthen your understanding. So you can also define the terminology engineering. Each definition emphasizes something. So you can define engineering as is a branch, say branch.
Branch.
So, and this is actually, you see that there's something we add in our mind. So engineering is a branch of science. So engineering is a branch of science, or is a branch of science and the technology. So you see, so in previous definition, you see only science. You don't see technology. So it's a branch of science. So engineering is a branch of science and technology. Concerned with what? So concerned with the design, building and the use of engines or machines, use of machines and structures. The means of engineering. It's a branch of science and technology concerned with the design, say design, building, and the use of engines. So when you say engines, we have aircraft engine, we have a train engine, right? We have boat engine, we have ship engine, So you have different engines, okay? And then you have also machines. We have simple machines and dirty complex machines. And the structures, for example, we have buildings, etc., etc. Right? Are we together? So this is another way that you can define the word engineering. So here you see that it's not only a branch of science, but also it's a branch of what? Technology. So it's that technology and science, that's what brings engineering. And especially that modern technology. Or you can also define the word engineering. Okay? Engineering is a use of, so you see again, is a use. So use here, it's a keyword. Use of, so it's the use of scientific principles to design. The use of scientific principles to design and build machines. Design and build machines. Build structures. Build structures. And the other items. Such as bridge, circuits, roads, vehicles, buildings, etc., etc. So simply, in engineering, we are using scientific principles. Principles to build, to design and build machines, structures and other items such as bridges, circuits, roads, vehicles, buildings, etc. So whenever we say that designing, it means actually that you should have design requirements, right? If you want to design something, we should have design requirements. What are the requirements for this design? And design actually involves mathematics and also involves thinking. Sometimes involves the use of softwares, right? But buildings, this is focusing on what? Once you have finished it to design, now you have to build what you have designed. Are we together? So building is actually focusing on what? Implementation. Right? Are we together?
Yes.
So that is engineering in general. Every field of engineering is focusing on use of science and technology. Okay, so that's all about engineering. We have the first terminology, which is applied mathematics. And you did the homework. So now, let me teach you a few definitions of applied mathematics, then you can check about your findings, so your solutions, whether you managed to get the correct definition or maybe you messed it up. But remember, there are different ways of defining every technology. Say applied mathematics.
Applied mathematics.
So we say basically in mathematics you have two categories, applied mathematics and pure mathematics. Pure mathematics actually focus on abstract. Say abstract.
Abstract.
And then applied mathematics is focusing on application. When you say pure mathematics focus on abstract, in most cases of theory, mathematical theories or mathematical theories in pure mathematics, you'll find yourself that you are learning mathematics by using letters more than numbers. That's what it means of abstract, right? Are we together? In
Yes.
pure mathematics, you'll be finding that many concepts have been explained by using letters and not numbers. Because that's the meanings of what? Abstract. So the fundamental question, this is question 4, which I asked you in your homework. What is applied mathematics? But our intention is not to know the meanings of applied mathematics, but we want to see that we want to build a concept in our mind that mathematics can be applied in electronics. So what is applied mathematics? I found some definitions for you, and here are them. Here are the definitions. So applied mathematics is the application of mathematical methods is the application of mathematical methods by different fields such as physics, engineering. We apply mathematics in engineering, that's what we call engineering mathematics. We apply mathematics in medicine, medical mathematics. We apply mathematics in biology. We apply mathematics in finance. We apply mathematics in business. We apply mathematics in computer science. We apply mathematics also in industries. So for example, our body's vision for Tanzania is to have Tanzania with industrial or with middle economy based on industry. So whenever that we think about industries, we have to think also about how we can apply mathematics. So we say that these are the applications of mathematics methods. For example, it's applications of integrations. It's one of the methods of mathematics by different fields such as physics, engineering, medicine, biology, finance, business, computer science, and industry. So in other words, we say that applied mathematics is not pure mathematics. Applied mathematics is a combination applied mathematics is a combination of mathematical science So it's a combination of mathematical science and the specialized knowledge. This is according to Wikipedia. So actually, applied mathematics, we need some concept from mathematics because we defined yesterday, or in previous session, the meanings of mathematics. So applied mathematics is actual combinations of mathematical science and specialized knowledge. What it means of specialized knowledge, for example, if you want to apply mathematics in electronics, it means that you should have specialized knowledge, the special knowledge about electronics engineering, right? And then you combine it with one or two or three mathematical methods. So from there, you have applied mathematics in electronics engineering. Are we together?
Yes.
Okay. In other words, or the other definitions, applied mathematics involves the applications of mathematics to problems which arises in various areas. I think that one of the students has given that definition. Example, science, engineering, and other diverse areas, or the developments of the new or improved methods to meet the challenges of new problems. So its applications of mathematical problems which arises in various areas, and the developments of the new or improved methods to meet the challenges of the new problems. So it means that sometimes new methods can be developed to meet the new problem. Okay? Are we together?
Yes.
Yeah. So for example, you find that as a human being, we had the problems of what? Okay. Yeah. So let's say that there's a problems of safety or security. So we find that maybe in mathematics, a particular model, particular methods will be developed in order to solve that new problem. Are we together? So just listen to the second definitions. I won't write it on the blackboard. Applied mathematics involves the application of mathematics to problems which arises in various areas. Example, science, engineering, or other diverse areas, and the developments of the new or improved methods to meet the challenges of the new problems. Okay? If you have any question, don't hesitate to ask. The fifth terminology. The fifth terminology that you need to understand in these modes of the beauty of fundamental practical electronics is electronics engineering. Now we know the definitions of engineering, but let us narrow our engineering concept into electronics engineering. Say electronics engineering.
Electronics engineering.
Good. So the fundamental question, what is electronics engineering? You can pause the video and then try to ask yourself, what is electronics engineering? Because if you won't ask yourself, then your children will ask you. My father or my mother, you told me that you learned about electronics engineering. What's electronics engineering? What does it mean? Then you can reply to them that I have never met such kind of a question in the exam. So you are the first one to ask me. So you should give me time, but you know, I was the first in the class. I had a high score. Not like you, who is the fourth one or the fifth. I was the first in the class. Okay, Daddy, you're the first. Okay, so now, what is electronics engineering? I want to understand. Okay, you have just to go and ask your teacher. Okay. So electronics engineering, actually, it's a branch of electrical engineering, or sometimes in some of the sources, they used to mention it's a branch of engineering, but it's a branch of electrical engineering. So there are various, there are the different ways of defining the terms electronics engineering, but the simplest definitions of electronics engineering is this one. Electronics engineering is a purposeful use of electronics science So electronics engineering is a purposeful use of what?
Science.
Use of, not every science, is a purposeful use of what?
Electronic science.
So there are there are electronic scientists who always used to think about to innovate in electronics engineering or in the field of electronics. Then you as engineer or technician have to think about how you can use the innovation to solve real life problems. Okay? Or in the other way, electronics engineering is a sub is a subdiscipline or branch of electrical So it's a subdiscipline or branch of electrical engineering which emerged as modern physics or modern physical science, which emerged in the early 20th century.
Bye.